In this video, my intention is to get truck drivers and any other interested person to learn how to apply physics on the diesel engine, just as an example of how to use physics in real life in general. So I am going to discuss the duality principle. Duality means the dual nature of things. Nature has a duality issue that works with particles and works with energy. Particles have inertia, energy has waves. So we have a duality of two things that control everything in our life. One aspect of the duality is the particles or the goods or materials, such as fuels, such as trucks, such as engines. And the other aspect of the duality is the energy, the heat, the light, and radiation. So the duality principle that controls matter and energy affects everything, whether it was transportation, whether it was your emotional relationship, whether it was your economical issues, anything in life you can apply to it the 6 laws of physics, which I'm going to discuss in this video. The duality issue splits the 6 laws into 2 groups. 3 laws apply to materials and the 3 laws apply to energy. And you are going to note that the 6 laws are intertwined, such that in the case of materials, we're dealing with inertia of a material object and the acceleration that have to overcome the inertia and the reaction of the inertia to the action. Those are the 3 laws of motion of material objects: the inertia, the acceleration, and the reaction. The other aspect of the duality principle is the energy. The energy does not have inertia, but it has a wavy nature. It propagates at constant speed, and we say energy flows. We don't say energy moves, because energy cannot be perceived unless there is matter, and the matter cannot exist unless there is energy. So the relationship between the two sides of the duality is a very intertwined relationship. On the energy side, we start from the temperature variation that guides the flow of energy. Exactly similar that the material, when we talk about inertia, the magnitude of inertia will guide the effect of the force to produce acceleration. The second law of thermodynamics, besides the temperature, is the law of conservation of energy. The conservation of energy means that energy have to come from well-defined sources and to have to exert well-defined functions, such that if you put certain amount of fuel in your truck, the fuel will have a specific amount of energy. The energy will produce a specific amount of force. The force will make you travel a specific amount of mileage. That is the second law of thermodynamics. And the third law of thermodynamics, the most interesting law, is called entropy. That is in the field of scientific community. For a common person, entropy can be interpreted as wear and tear of material due to the effect of heat and the variation of temperature. Therefore, the present video is a very critical educational tool for anybody, whether you are a trucker with education, with no education, whether you are an academic who wants to see how common people discuss issues that are critical to scientists, but that scientists have difficult time to convey those fundamental rules and laws of physics to the public. I hope you will enjoy this lesson in the School of Hard Knocks, a crash course in the physics of nature. Well, this scene reminds me of an incident when I left a set of tools like that on the steps of the truck, and I traveled from New Jersey to Washington, 3,000 miles, and I was able to find the set of tools sitting exactly in the same spot for 6 days during the winter, traveling from New Jersey to state of Washington. Look at the background. We are in Arizona in July. The temperature is 114 degrees. So I will see how long can I stand in the heat. I will try to explain to the YouTube viewers the fundamentals of science, how to apply science in real life. So let us start by very simple application of the 6 laws of physics on the design of a heavy duty semi. The 6 laws of physics are simply split into 2 groups. The 3 laws of motion, Newton's first law, Newton's second law, and Newton's third law. The 3 laws of motion apply to material objects. It describes the motion of an object that has a mass It relates the mass, the speed of the mass, and the force that's applied on the mass. The 3 laws of motion are the Newton's first law of inertia, Newton's second law of the amount of motion or acceleration, and Newton's third law of action and reaction. Newton's laws of motion apply to material objects. They describe the motion of the object in space and time. The other 3 laws of physics are the laws of energy or laws of thermodynamics. The first law of thermodynamics is the law of the temperature. The second law of thermodynamics is the law of conservation of energy. And the third law of thermodynamics is the law of entropy, a reversibility of entropy. Well, how do you apply the 6 laws of physics to a mechanical design? You cannot really design anything mechanically unless you combine the 6 laws. Let us start from a very simple mechanism, the steering mechanism. How to apply the 6 laws of physics on the steering mechanism. The first law of physics is the Newton's first law of motion that states that material objects resist change until a force is applied to them. It is called the law of inertia or the law of resistance of material objects to change in their state of motion. Sorry. Here is the steering system that we have. The steering column coming from of the front wall of the driver cabin. That's the steering column. It has a very universal joint here and some joint inside and another universal joint here. And here is the differential gear that convert the motion from one direction to another direction. And you have the arm that comes out from the differential gear, and you have some leverage. It transfers or transmits the mechanical torque from the steering column to some gears inside to an arm connected to another arm connected to a third arm, and you end up by having to steer this tire and the tire on the other side through this part that goes across from under the suspension to the other side. Newton's first law states that a material object resists or has the inertia to resist change of motion until you apply force on it. Where do you get the force? You get the force from the hands of the driver. The driver steers the truck using the steering column. So the force comes through this column. The force is applied by the driver. With these universal links, you end up by applying the force inside the gearbox that is lubricated, as you see. The fluid starts from this column, going in the bottom. This is the outlet of the reservoir. It goes through inside that beam. It comes from this hole, go inside the differential, or what you call it, steering pump or steering differential. It lubricates it and it returns back. The differential transmits this force from here, the steering column force, into an intermediate lever. As you see, the function, the length of the lever will magnify the force applied by the driver's hand depending on how long this arm is. So you end up by having a force at this point that is multiplied many times by a certain factor. The driver's hands force multiplied many times, and when it comes to this point, then you have another lever and another joint here. The length of this lever, the length of this lever and the length of that lever determine how much force you end up by applying to the wheel. With this force starting from the driver's hands and being magnified or manipulated by the differential gear and transmitted at the end to the steering wheels, will be able to control the entire vehicle direction. We are controlling 40 tons of materials on a highway through this kind of simple mechanism. So this is the beginning of the force, and the mass is the mass of the tractor and the trailer. That is law number one, Newton's first law of motion. Newton's second law of motion states that the amount of motion you get by applying a force is proportional to the amount of force you impart on the material object. So the more force you put here, the more acceleration you get here, or the more force you get here. The more force you get on this as the lever, the more motion, the amount of motion increases as you increase the force, which simply means the more force you put on the steering, it changes the steering angle, the direction of this wheel and the other wheel, depending on the magnitude of the force. To put it in a mathematical form, the second law states that the force equals the mass multiplied by the acceleration. That is the second law of motion. Now we apply 2 laws out of 6. The third law is very simple. The third law says every action has to have an equal and opposite reaction, which means the reaction is equal in magnitude to the action and different in direction. That is a very simple law to apply. You look carefully, you will see the steering pump is right here. Look at how many bolts are fixing. That's 1, that's 2, and that is 3 bolts are fixing the steering pump. Why do you have to fix the steering pump? Because the steering pump is having 2 forces applied to it. The input force is coming from the steering column, and the output forces that coming out through the differential gear connection. With these 2 forces, the steering pump cannot support these 2 forces unless it is anchored in the frame of the truck. The engineer who configures how to connect, how to bolt, structure the steering differential, how big should he use the bolts, what kind of material should the bolts consist of, how thick are these arms. Each one of these components have to stand the force that you applied on it after magnification. So the action is the action of the steering column, and the action of the differential gears, that's the outlet action, the input action and the outlet action. The reaction applies to the strength of these bolts. If these bolts cannot stand this kind of balance between forces, the steering pump will fly, will break out and crack, and you are not going to have a steering mechanism. That is the third law of motion, or Newton's third law of action and reaction. We already explained the 3 laws of motion on the steering mechanism of a semi-tractor. Now let us go to law number 4, or the first law of thermodynamics. The first law of thermodynamics states that the heat moves from the hot surface to a cold surface. How do you apply that law? Why do you have to have a steering oil reservoir? Why don't you just put the oil inside and seal the pump, and the pump will take care of itself? If you do that, if you don't have this mechanism of rotation of steering fluid from the input to the differential gear and the outlet, and without that kind of circulation, the temperature will increase enormously inside the gearing mechanism, and that pump will melt. So the reason that you have the oil reservoir is because when the oil evaporates or becomes thick because of the heat, you can cool it through this circulation. There is not much cooling surface here, but you can tell where else can you find a better cooling surface. You can ask me, where is the cooling surface? there is some cooling because you're getting the fluid in and out. This distance from here, from the outlet of the oil, that hose going through this plastic reservoir, returning from, it is hot, returning to the other side and coming here, it's cooling enough for it. Still, another thing, it also has a metal surface that can cool it a little bit. A much better way to explain the first law of thermodynamics is that cooling system right there. Here is the coolant pump, here is the hose, this is the coolant hose, and this is the radiator, and that is the fan that cools the radiator. That explains better the first law of thermodynamics. The engine gets hot, you have to get the heat out through the coolant, you dump the heat in the radiator, you turn the fan on, you expel the heat to the environment, or you can use the heat to heat the driver cabinet, and you return from the other side the cold water. Now let us for the fifth law of physics, or the second law of thermodynamics, that states that the energy is conserved, or the conservation of energy. The law states that you cannot create energy from nothing, and the energy have to do something. You have to explain where the energy goes. That is the second law of thermodynamics. How do you apply that on the steering mechanism? The driver eats hamburger, French fries, goes to the gym, have some muscles. The driver steers the steering column. How much force does it come? How much magnification? You take the diameter of this column, the steering column, you take the diameter of the steering wheel, and you divide the diameter of the steering wheel on it. Tell you the magnification of the force, of the human force of the shoulder, the deltoid, the biceps, the forearms, that is applied through this column. So that force, how do you get from the force to energy? We are talking about energy. Energy equals the force multiplied by distance. The distance means how far does this go. The more energy you put, the more rotation you get here. So the force you applied to the steering column is going to be energy. The energy is applied through the differential gears. The force from here to here, you will get multiplication in force sufficient enough to move this entire tractor trailer. So where did the energy go? The energy was spent in moving this wheel, moving the entire truck, and radiating heat from the differential gearbox of the steering column, and some heat burns the oil. The oil have to change every few years. So you cannot steer the truck by just imagination. You have to steer it by imparting force on it or delivering energy to it. And the truck have to take your energy and convert it to a steering energy that steers the entire truck. And I'm going to move to the third law of thermodynamics. I'm still standing, okay, in the extreme 114 temperature of Arizona. Let us now complete the first law of thermodynamics. Here is a simple mechanism to explain to you the first law of thermodynamics. Okay, some hot water have to go to the radiator, and some cold water have to come back from the radiator, and the pump is in the right there with the bolt on it. The coolant pump and the fan that cools the radiator is right there. So in the first law of thermodynamics, that states that the engine produces heat, gets hot. If you don't lower the temperature, the material object or the engine will crack and melt down. So you need to keep the engine running at the maximum tolerable temperature allowed for the engine, which I think here is 180 degrees Fahrenheit, slightly under the boiling temperature of water. Now, the third law of thermodynamics is a very complicated law, and a lot of people don't like it, and no teacher wants to teach it, and the schools do not like to teach it, and you leave it until you get to the graduate schools, hoping that the graduate students will be mature enough to understand what you explain to them. The third law of thermodynamics is called the law of irreversibility of entropy. The entropy, let me just explain it to you in a very simple language. The entropy is the amount of deformation you have due to pumping energy and changing the temperature. You put energy, you have a steering energy right here. What is going to happen to the oil? The oil is going to last not forever. That oil is going to last for a few years. Why? Because you keep changing the temperature, you keep heating and cooling, heating and cooling. All these parts, all these joints, you have, as you see, we have grease here. We have grease here. We have a jacket here and the grease. You have grease everywhere. Why do you have to have grease? Because when you move things over the time, there is a wear and tear. That wear and tear, we call it entropy. The entropy means, mathematically, the amount of entropy is described as the Q over T. Q is the amount of heat divided by the absolute temperature of the object. Let me explain it again. Mathematically, the entropy is represented as the amount of heat Q divided by the absolute temperature of the object. The absolute temperature means you get the temperature in Fahrenheit and you add a certain number, 450 degrees, to get the absolute temperature. If you're working with centigrade, the temperature in centigrade, you add to it 273. That is the laws of physics, and I'm not going to get into it now. I will get into it later on. So the entropy is a deformation. A common person will say, well, the entropy is the wear and tear, which means simply the more energy applied to any part of this engineering design, the more motion you have, you get out of that design, the more temperature changes variation you apply at that point of design, the more wear and tear will take place. We now covered the 6 laws of physics, and I still have my head is boiling. I'm covering my head, and I will give you a final view before we leave this place. I will give you a quick look. This area is called Littlefield Cemetery in Arizona on I-15, just 10 miles before we enter the Virgin River Canyon. That's enough for today. I stopped here to show you that the temperature is 117, and we are now in the middle of the canyon, the Virgin River Canyon.